Curvilinear coordinate system 6. Perform the following line integrals along 1/4 of a unit radius circle traversed in a counterclockwise direction. The center of the circle is at the origin of a Cartesian coordinate system, and the quarter circle of interest is in the first xy quadrant. Part A, the contour line integral dr dot v, where this vector v is 2x ex hat, and part B, the line integral dr phi, where phi is a scalar function 2x. Okay, so the path we're talking about is on the xy plane on the unit circle in the first quadrant. We're going from x equals 1 to 0, y equals 0 to 1, so along this path. All right. And let's note a few things here. The position vector on this path, r, is equal to x ex hat plus y ey hat, because z is equal to 0. And I have to have x squared plus y squared is equal to 1. And y is positive because we're in the first quadrant. X is positive and y is positive. We are in the first quadrant. Now, for y, I can write square root of 1 minus x squared. So that's what I'm going to do here. The position vector r is x ex hat plus 1 minus x squared square root ey hat. Now the displacement vector dr is then dx ex hat, and if I take a derivative of this with respect to x, I will have plus 1 over 2, because it's 1 minus x squared parenthesis to the power 1/2. The derivative of inside minus 2x, and then I have 1 minus x squared to the power minus 1 over 2 dx in ey hat direction. All right. So let's clean this up a little bit. These 2's will cancel. And I can write my displacement vector, differential displacement vector dr is dx ex hat minus x dx divided by square root of 1 minus x squared ey hat. Okay. So let's start this calculation. Our vector v is 2x ex hat. Then I'm going to calculate the dot product of displacement vector with vector v, dr dot v. The displacement vector has dx ex hat in ex hat direction. Therefore, this is 2x dx. Ex hat dot ey hat is 0. So this term doesn't give me any non-zero answer. So the contour integral dr dot v is going to be the integral x goes from 1 to 0 along this path. So x goes from 1 to 0, 2x dx, which is the integral of 2x dx is x squared. That will be evaluated between 1 and 0. So the answer will be, for the contour integral dr dot v, it is evaluated at 0, it's 0, minus evaluated at 1, 1, so it's minus 1. That's the answer to part A. Now in part B, we have a scalar function. Phi is equal to 2x, position dependent. And for the contour integral, dr pi, we can have x goes from 1 to 0. For dr, I have dx ex hat minus this, x dx over square root 1 minus x squared ey hat. So multiplying it by 2x, I have 2x dx ex hat. And then I have minus this multiplied by 2x gives me 2x squared minus 2x squared dx divided by square root of 1 minus x squared ey hat. All right, I'm going to call this integral, the answer to this integral a, and the answer to this integral b. So let's work on a first. A is simple. A is the integral from 1 to 0 2x dx ex hat, which is x squared ex hat, where x will change from 1 to 0. Therefore, the answer is minus ex hat. Now for b, let's see, I have b is equal to integral from 1 to 0 2x squared divided by square root of 1 minus x squared dx in ey hat direction. So I'm going to make a substitution for x. What if x is equal to sine theta? So that means I'm talking about this right triangle here. Sine theta is x. Cosine theta is square root 1 minus x squared. So square root 1 minus x squared is cosine theta. And dx is derivative of sine cosine theta d theta. So the other thing I have to pay attention to is when x is 1, theta is pi over 2. When x is 0, theta is 0. So this is going to give me for b integral from pi over 2 to 0, because x equals 1 corresponds to theta equals pi over 2. X equals 0, theta equals 0. 2x squared, so it's 2 sine square theta. Dx is cosine theta d theta. And square root of 1 minus x squared is cosine theta. This is in ey hat direction. Now you can see that these cosine thetas will cancel out. I will be left with integral from pi over 2 to 0. For 2 sine squared theta, you can see that I can substitute 1 minus cosine 2 theta. So this is 1 minus cosine 2 theta d theta in ey hat direction. So b becomes the integral of d theta is theta, and integral of minus cosine 2 theta is minus 1 over 2 sine 2 theta. And this whole thing will be evaluated between pi over 2 and 0, and it's going to be in ey hat direction. Evaluated at 0, I'm going to obtain 0. Evaluated at pi over 2, the sine will become sine pi, which is also 0. Therefore, I will have pi over 2 from theta. So 0 minus pi over 2, I will have minus pi over 2 in ey hat direction. Now I can put it together. For the contour integral, dr phi, I have obtained, basically this is a, this is b, the integral of this is b. So I have a minus b as the answer, a minus b, which is going to give me minus ex hat plus pi over 2 ey hat as the final answer. Okay, so in this problem we're talking about two contour integrals, the dot product of a vector with the displacement vector dr, or a scalar function multiplied with dr vector. Vector b is 2x ex hat, and the scalar function is 2x. So first I have worked on this contour that was defined to me, which is on the xy plane, on a unit circle going from x equals 1 to y equals 1. It's in the counterclockwise direction. The position vector on the xy plane is x ex hat plus y ey hat. And on this contour, x squared plus y squared equals 1. And for that, I can substitute y equals square root 1 minus x squared. And it's the first quadrant. dr is basically the derivative of this dx ex hat plus derivative of square root 1 minus x squared, which is minus x over square root 1 minus x squared dx ey hat. So this is my differential displacement vector. V vector dot product with the differential displacement vector, ex hat dot ex hat is 1, so that gives me 2x dx, ey hat doesn't give any contribution, and x goes from 1 to 0, 2x dx, so this gives me x squared from 1 to 0, which is minus 1. As for the function phi, 2x, I have 2x dx ex hat minus 2x squared dx over square root 1 minus x squared dx ey hat. And x goes from 1 to 0 on this path. And I called the integral 2x dx ex hat a. That's integral from 1 to 0 2x dx ex hat, which is x squared ex hat from 1 to 0, which is minus ex hat. And I called the integral 2x squared dx over square root 1 minus x squared ey hat b. And making a substitution of x equals sine theta, I realized that this is cosine theta. The top part is cosine theta d theta. Cosine thetas cancel. I have 2 sine squared theta d theta. 2 sine squared theta is 1 minus cosine 2 theta. And as x goes from 1 to 0, theta goes from pi over 2 to 0. So this integral gives me theta and minus 1 over 2 sine 2 theta. Sine 2 theta part gives me 0 for these limits, but theta part gives me minus pi over 2, so it's minus pi over 2 ey hat. My answer is a minus b for the contour integral, so it is minus ex hat plus pi over 2 ey hat.